Hey there, I'm Ken. This is Canadian Retro Things, and today I am going to look at my color computer 2 that has the banker switch in it. That's right, I am going to see if I can get that CoCo 2 with the 256K banker switch working. Now, I know L. Curtis Boyle tested it before he handed it off to me, and he could only get the initial 64K working, and I think I know what the problem is. I think it's a simple fix, so hopefully it's going to be a simple fix. Now, I don't know a lot about the banker switch. I don't know a lot about using it, and this is definitely going to be the very first time I've ever used one, so this is going to be a learning experience for me, and I hope a learning experience for you. So with any luck, we'll have that banker switch humming by the end of this video, but first, I would like to thank the sponsor of today's video, PCBWay, without whom many of these videos that I make would not be possible. PCBWay, where you can get PCBs printed starting as low as $5 for 10 PCBs. Yes, $5 for 10 PCBs. So if you have a project that does something like, say, bump a 64K retro computer up to 256K, you don't have to spend a fortune prototyping it. Are they fast? Are they fast? The build times start at 24 hours and can be faster if needed. That means you can have your PCB in your hands in a couple of days. That's with shipping, of course. So, why not visit PCBWay today at www.pcbway.com. Today we're going to be looking at the 256K banker switch CoCo 2. Now, interesting thing about it, you can see color is spelt properly, which means this is the Canadian version, or it could be a Australian PAL version or a UK PAL version, but this is an NTS version, so it's the Canadian version. However, if you look inside the box, they do spell it color on the Radio Shack badge here, which I don't blame them for, because I'm sure that these are just mass produced and they only had decided to print the one badge. I don't know if I've ever seen it spelt COLOUR on the badge, but you can forgive them for that because this is usable throughout all of North America. On the back, however, they printed the back stickers in both English and French as required in Canada. However, with the English color, they spelt it the American way. If they were printing these specifically for Canada to have both the French and English on it, why didn't they spell color COLOUR? I don't know. They did it on the box. They just didn't do it on the computer. That's just a weird little quirk. Anyways, yeah, I guess we're going to take this apart and look on the inside. Before we open up that computer, I just wanted to show this did come with two manuals, both from January the 2nd, 1986. The user manual and the installation manual. The user manual basically just has a lot of information about some of the test programs that go along with this and how to use them. The more important one today is, of course, this installation manual, which goes through step by step how to install the banker into the computer. It's got some nice diagrams at the back about how the optional switch is installed, which is, I think, the thing I have to install here to get this working properly. So that switches between 64K and 256K. And it also shows how to have the memory chips connected together and then to the banker board. On the CoCo 1 and CoCo 2 version, different version of the CoCo 2, and yet a different version of the CoCo 2. All right, well, now let's take the computer apart. Now there are the manuals like this available on the archive, although I think these are slightly older versions because the ones on the archive also include instructions for the 512K board, which I don't think at the time these were printed was available. All right, we have the screws out of this case. Interestingly enough, it actually had all of its screws. Now, let's take this off and see what it looks like on the inside. There we go. So, we've got 2 additional boards in here. This is the banker board, which gives the 256K. And you may recognize this as the composite upgrade board. That is something I was doing on my other CoCo 2 with the Melty keyboard. So let's remove this keyboard so we can have a better look at everything. All right, well, you can see how pin 1 of each of the memory chips here are tied together, just like in the diagram in the instruction book. Going into the banker board here, which plugs into the SAM chip socket. And actually, you know, looking at this composite board, I still haven't gotten the one working properly on my other computer. And these 2 wires here should probably have a switch hooked up to them. Because if you look on the diagrams provided, these should be the switch for the 64K and the 256K. So, I've got a little switch right here. I can just solder onto there. It's supposed to be a 2-pole switch. This is a 3, so I'll just use 2 of the poles, the middle one and one of the others. All right, well, let's attach this to there, and then we can plug it in and try it out. All right, I have connected a switch, so no connection. Connection. So that should work. So let's put the keyboard back on here, plug this sucker in, and see what happens. All right, I've got the computer hooked up, ready to fire it up and see what happens. Okay, we are not getting any color. All right, so I contacted L. Curtis Boyle. He tested this machine before I picked it up from him. He said when he first tried it, there seemed to be a problem, but he just jiggled some stuff and it started working. That does not seem to be working for me, though. I have the worst luck with these color expansion boards. Okay, I'm just going to try a few things. I'll be right back. See, I was getting a completely black screen a minute ago. Now I turn the camera on, and it seems to be working. What exactly did I do to get the color working here? Well, as you can see, right down here, there's a little arrow, and that's where the green line was attached. Now, if you actually read the original schematic for this board, the green line is supposed to be attached in there. Of course, it's really dark in there, but if you can see that, right back there, there's a resistor right beside the chip that it's supposed to be attached to the bottom of. Bottom being the closest to the motherboard. So that's what I did, and now it works. Working with the switch in one position. And this position right now should be on. So it should be on the 256K right now. $64K. All right, it's working. I don't know what's going on there, but yeah, it's working. That's the important thing. So I guess I now have to figure out how to test to see that it's actually 64K and 256K. Now that I've got the composite board working properly, it's time to test the banker switch board. So rather than looking through all of those disks that I received for the software that I need to run this, I'll of course use my handy dandy CoCo SDC. And I just downloaded the program I need off of the CoCo archive, the Color Computer archive. So it is ready to go. Should be currently set to 64K. And yeah. All right, so I'm going to be running the bank test, as you can see there, on the 64K. Now the way that this is designed, there's basically 4 banks. There's 0, 1, 2, and 3, and they are divided into high and low, each one being 32K. So the fact that it's set to 64 should mean that if I run this and I do the automatic, it should just detect the bank 0. Lower bank 0, upper bank 0, abort, 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 abort. Okay, that's basically what I thought would happen. That just means that there's 2 banks of 32K that it can read. So we shall shut it off and switch it to 256. Now we'll read the same thing. So this time it should read the upper and lower banks of all 4, 0, 1, 2, and 3. Automatic. Lower 0. Upper 0. And it's aborting. Okay. That's not what's supposed to happen. The P-copy demo is supposed to use all of the 256K. So can't switch to bank 1, can't switch to bank 2, can't switch to bank 3. Okay, so something is not working. Let me just fiddle around with a few things, see if anything is loose or what. Fortunately, everything in the banker board is socketed, so I'm going to take it out, try reseating everything, maybe a little contact cleaner in it, and go from there. As I was reseating all of the chips and spraying a little deoxit into the chip holders, I discovered something. Pulled the board out, And what did I discover? A big old blob of corrosion. And on this side, if you look at it, you can see that the corrosion is right there and there, right around this capacitor and onto this resistor. Hopefully the lines are still making connections. If not, I'll have to add some kludge wires to it. And yeah, hopefully I have the required capacitor and resistor in my collection of spare parts here. If I don't, I gotta go buy some, which may take me a little bit of time. So after a very exhaustive, almost full day search, I finally found my parts. Just a little rant here, but don't you hate it when you think you've put something somewhere and it's not there? After looking for these for about a half an hour, it became a mission for me. I tore my house apart looking for them. Now, as many of you know, I just got back from my cabin, and yeah, these were under the seat in the car. I had not unpacked them yet. I thought I had. I hadn't. Anyways, the good thing is that I actually have the parts I need to do this now. The bad thing is that I've just wasted the day I was going to spend fixing the board looking for the parts. So there's going to be a part 2 to this video. And we're going to be ending now. The good thing is that this also gives me a little extra time to research this board and make sure I'm not going to screw anything up. And yeah, just not rush the process. Alright, so the video is ending here. I hope you enjoyed this video. If you did, you know what you can do with the liking, the subscribing, and the commenting below, because anything and everything you do is always greatly appreciated and helps the channel out a lot. So I hope you're going to join me for part 2 of this video, when hopefully we will finally get this 256K banker switch working. Until then, have a great day.